Holy moly, another section done, and we're getting so close to the end. In this section, we learned about searching and traversal, some of the most popular and important algorithms. We learned about linear search and how it can be good for some cases, but not the most efficient because it has linear time, O of n. We also talked about binary search, where we're able to search through things at log of n, essentially skipping a lot of the nodes that we would need to search by dividing the tree in half. We then talked about how to traverse a tree and a graph, that is, to visit every single node in the most efficient way possible. We talked about depth first search, that goes in as deep as possible into a tree or a graph, and breadth first search, that goes level by level, searching or traversing a tree or a graph. And whether you realize it or not, we've completed a lot of this mind map that looked so intimidating at the beginning of this course. You see, now, when we look at arrays, for example, we understand that, well, when we need to search through an array, we can ask the question, hey, is it sorted? Because if it is, then yes, in that case, we should divide and conquer and arrange that array in a tree-like data structure so that we can do binary search and get a speed boost of O log n. Is the array not sorted? Well, no. Then it's actually more efficient to sort the array, even though it takes O of n log n, as we know over here, and then do a binary search after we sort it. And a lot of programs do that. Although it may seem time-consuming to do sorting and then searching, it is actually faster than perhaps doing a linear search over and over. But we can also complete this part of the graph, where we come to graphs and trees. When we do traversals, that is, try and visit a node in a tree or a graph, or all nodes in a tree or a graph, we know that it's going to take O of n. That is, we have to visit every node. It's going to be linear time. But there are ways to traverse these trees using breadth first search and depth first search. And we learned that breadth first search is great for the shortest path algorithms, while depth first search is really great at maze solving problems, or perhaps finding if a node even exists. And depth first search allow us to do in-order, post-order, and pre-order sorting. And we even coded this up all ourselves. And we learn how the code works using recursion with depth first search and also with breadth first search using both iterative and recursive using a queue data structure. Finally, we also learned a little bit about shortest path problems, such as the one that Google Maps would use when there's weights between nodes in a graph, where we can use something like Bellman-Ford or Dijkstra's algorithm to solve a problem. Congratulations. This is your mind map, and you've covered every single thing on this map, with the exception of one, and that is this one right over here, dynamic programming. It's a short section to complete our overall mind map and get you interview ready. So I'll see you in the next section. Congratulations getting this far. You're almost there. Bye-bye.